Download this code from codegive.com, link in the description below. Building reliable systems using unreliable components is a common challenge in software engineering, especially in distributed systems or microservices architectures. The goal is to design systems that can withstand failures of individual components while maintaining overall functionality. This tutorial will cover key principles and patterns to achieve this, along with a code example. Key principles. 1. Redundancy. Use multiple instances of a component to handle failures. If one instance fails, others can take over. 2. Graceful degradation. Allow the system to continue operating, albeit with reduced functionality, when certain components fail. 3. Retries and backoff. Automatically retry failed operations with an increasing delay between attempts to avoid overwhelming failing components. 4. Circuit breaker pattern. Prevent the system from making calls to a failing service for a certain period, allowing it to recover. 5. Timeouts. Implement timeouts for operations to avoid waiting indefinitely for a response from unreliable components. 6. Monitoring and alerts. Implement logging and monitoring to detect failures and take corrective actions. 7. Fallbacks. Provide alternative responses or services when a component fails. Code example. Let's implement a simple service that fetches user data from a potentially unreliable external API. We'll use Python with the requests library and implement some of the principles mentioned above. Explanation of the code. 1. Circuit breaker class. This class keeps track of how many consecutive failures have occurred. If it exceeds the threshold, it opens the circuit, preventing further requests until a recovery timeout. 2. Fetch user data function. This function makes a network call to fetch user data. It is decorated with the circuit breaker to handle failures gracefully. 3. Main function. The main loop attempts to fetch user data multiple times, simulating a scenario where the external API may fail intermittently. Conclusion. By implementing patterns like the circuit breaker, you can build reliable systems that gracefully handle failures of individual components. This example provides a foundational understanding, but in real-world applications, you may want to incorporate more sophisticated error handling, logging, and monitoring solutions. By adhering to these principles, you can create systems that maintain functionality even in the face of component failures.